Welcome to week 3 in statistics. This week we're going to look at summary statistics. So we've already started looking at summary statistics. And if you paid attention when you were playing with StatKey, if you used it, they give a list of some of the summary statistics here on the side. So we've looked at minimum and maximum, quartile, median. Some new ones we're going to look at this week are mean and standard deviation, in addition to mode is another one. So here, for example, it says the mean is 7.9, which is a little lower than the median, which is 8. Well, let's look at that on our graph. So here I just copied that in so I can draw on it. And these numbers represent roughly the center of each group here. And so we have a median of 8. And the mean is just a little bit lower, 7.9. So that one there's the mean. And mean, more technically, it's called the arithmetic mean. Means average. And you've been working with average for a long time in different math classes. It's just the sum of the values divided by the count, how many, the sample size. Notice here that the mean is a little lower than the median, and that happens sometimes. Notice this data set is skewed, and I guess I would argue it has a slight skew to the right because there's more of a tail away from the mean and the median. And the mean is usually more affected by outliers. So we'll take a look this week at another idea of what it means to be outliers. Last week we looked at that in the idea of a box plot. And here, StatKey shows outliers, so they draw a different kind of box plot than the book went over, where they take that interquartile range and they move it out just a little bit to mark where normal is for the data, and then anything beyond that ends up being an outlier. So here we have one, by the way, this is the percent uninsured by state data that I just pasted in here into StatKey. Okay, so let's take a look at a spreadsheet. So here's my spreadsheet from application 2, where I needed to make a frequency table and a relative frequency table. And this is important. When you make a frequency table, use the same groupings to come up with the relative frequencies, because these frequency numbers are what give you the relative frequency. I just take 7 and divide by the total of 52 items in this list. So that's something I should have here in my summary statistics. So notice I used the min and the max and the range to guide me on how to set up my groups. I decided to have 8 groups. Count of the data is also useful, which the spreadsheet does quite nice with the count command. I just highlight the numbers. And so here I get a count of 51 numbers. So interesting. Oh, I guess we just count the District of Columbia as extra. Okay. Other summary statistics that would be useful to see here are the mean, which is also the average. This is the average command in your spreadsheet. And here, I don't want to use the column heading to highlight the whole column because there's other things in this column. And that's super important in this particular case because I have the whole United States, but the United States takes into consideration all of these numbers below, so it would be redundant and inaccurate to include that percent uninsured in the United States with all the other states. So if you use that in your frequency distribution over here, then that's inappropriate. So That is a separate, different kind of number than these other ones, because these are states within the US. So mean is there. Now standard deviation I'll talk about in just a minute, so I'll call that STDV. And there's a whole bunch of different standard deviation calculations. On a spreadsheet, the standard one, STDEV, that's the standard deviation of a sample. Up here they have STDEV A. That's pretty close to the standard one, STDEV, the basic one. It just treats text as zeros, whereas this one right here just ignores text. This A also calculates a sample standard deviation versus the population standard deviation and the population standard deviation that treats text as zero. So I'm just going to use the standard. This is for a sample, and then I just highlight my data. Close parentheses. And I had fed stat key the same set of numbers, Alabama through the rest of them there. I get 3.044-ish. And if I look back at the stat key information, there's that 3.044 value. And what standard deviation is, it's a measure of the average spread of the data. So it's a measure of the average spread. There are other measures, but we're not worried about them. So breaking that down a little bit, the idea of deviation. Deviation is just the distance from the mean. So we have a mean here. Mean of a sample is denoted by X with a bar over it. And our mean was 7.9. Now let's look back at the data and consider a specific number. Like, I live in Oregon. Oregon has a value of 6.2 for the percent uninsured. So some X value in the data, in this case 6.2, which represents Oregon. Now, if I take my value and subtract the mean, that gives me 6.2 minus 7.9, which ends up being what? Negative 1.7. So it tells me two things. The negative tells me that Oregon is below average. And it tells me by how much. So if we were to do a similar thing with, say, Mexico, Mexico has a bunch of regions like states, and we calculated the percent uninsured by state in Mexico, and then we found the average for all of Mexico. We would have a different mean, right? And so just comparing means directly of two groups is kind of inappropriate if you don't know how spread out the data is. So we have to take that into account too. So we use mean and standard deviation together when we're comparing two different populations. And so what we do to calculate standard deviation is we find the deviation of all items in our list. That tells us whether they're below average or above average. So I could do that in my data here. So I'm going to add an extra column. Let's see, I need my column left. There we go. So I'm just going to calculate deviation. Deviation is simply whatever the data value is minus the mean, which is 7.9. And then I can just fill that down. And so what I'll see is some states are above average, some states are below average. Now, because the mean marks the center in a certain way, the above average states and the below average states are going to balance each other out. So if I were to add up all of these deviations, what I'll find is they sum to 0 because the mean's in the middle. Balances, but oh, that's crazy shit. Try that again. Balances the above average and the below average. So add up all my deviations. So I get a sum of 0 down here at the bottom. So I can't just do a direct average on the deviations because that'll always give me 0 because the mean is in the middle. So standard deviation, what it does to deal with these positives and negatives is it squares all these numbers first and then later takes the square root. So if you look in the book at the formula, so that would be in 2.7, you'll see it's got this wild and crazy formula. There we go. Blow that sucker up a little bit. And you really don't need to know the formula. So basically what this formula says is for a sample, take every x value, every number in the data, and subtract the mean from it. Then square those numbers. And then this right here is Greek sigma, means add them all up. Okay, so like I did earlier, but I'm adding up the squares of the differences, the square deviations. Then in a sample, you divide by n minus 1, so the sample size minus 1, and then you take the square root of all of that. Kind of a complicated formula, but we have a button that does the same thing. So right there, bang, super easy. So we don't need to know the formula really, but we do need to know it's related to deviation. Deviation is just distance from the center. So like I said, standard deviation gives us the average spread of the data. So if I look at that idea on the graph again, let's go back. So here's 7.8. Oops, it's supposed to be 7.9. How did I do that? You guys should have told me. I miswrote that. So 7.9. Oops, wrong color. No biggie. So from 7.9, if I take that standard deviation, let's call it 3 for ease. It's pretty close to 3. So standard deviation for a sample is the letter S, and I'm going to say S is approximately 3. So what I would get is 10.9, which would be right about here. So that would be one standard deviation to the right. So I could say that's X bar plus S. And I could add it again, and I could get 13.9. So that's going to put me right about here, right? No, sorry, 13.9 would be right about, did I do that right? 10.9. Oh no, that's almost 11. Oh, I'm adding 3. Yeah, 13.9. So that's going to be right about here. Oh, I lied again. Do that. I'll get it right this time. That's close to 14, so that's about here. That looks better. And that right there would be X bar plus 2 standard deviations, X bar plus 2S. So I'm 2 standard deviations to the right. Similarly, I could go the other way. So subtracting 3 from the mean, that's going to give me 4.9, which is about 5. And if I do that again, it's going to give me 1.9, which is about 2, right about here. So this would be X bar minus S and X bar minus 2 S's. So here I'm 2 standard deviations below the mean. Over here, I'm 2 standard deviations above the mean. And what we expect is that if I look between those two numbers, I expect most of the data to be within 2 standard deviations of the mean. Most of data is within 2 standard deviations of the mean. And in general, people say it's around 95% of the data will be within 2 standard deviations with the mean. We can also use that as a measure of outliers. So another measure for outliers in addition to the box plot method, is if something is more than 2 standard deviations from the mean, it's unusually high or unusually low. So more than 2 standard deviations from the mean. Then we say that's unusual. I could spell. So if we look at our data back in the spreadsheet, we can see we have a max of 16.6. And looking at our, see, where'd you go? Here we are. Picture with the standard deviations marked. That's way out here. That's higher than 2 standard deviations from the mean, which was right there. So that would be considered an outlier. On the other hand, our low, let's see, was what? I didn't write that down here. Standard deviation is about 3, so 2 would be 6. 7 minus 6 is 1, so that was around 2 over here, so 1.9-ish. There's 2 standard deviations below. Now our minimum in this data set was 2.5, so there's no state that is unusually low in the percent uninsured, but there are states that are unusually high compared to the rest of the states. So if I look back at my data again and I do a little search, nice search on spreadsheets and web pages is Control F if you're a Windows user, Command F if you're a Mac user, and I'm looking for 16.6, and it comes up twice, and there it is, Texas. So Texas is unusually high in the percent uninsured for 2 reasons. 1, it's more than 2 standard deviations from the mean, and 2, if we look at our box plot, it sits outside of that extended interquartile range. So I have 2 calculations that say Texas is unusually high in its percent uninsured. Let's see, scrolling through the data, we got a 13.8. What else? Seems like that's about, oh, there's a 14 in Alaska. And according to my rough calculations over here, yeah, Alaska is barely outside that edge right there. But Alaska is marginally large compared to the rest. Texas is unusually large for sure because it's way outside that. So I may want to count, well, how many standard deviations is Texas from average? So let's take a look at that. So what we're going to do next is we're counting standard deviations. And with Texas, its percent was, I believe, 16.6. And if I want to find its deviation, I would just take 16.6. So, right, we take the value and we minus the mean. So for Texas, that's 16.6 minus 7.9, which is going to lead to what? 8.5, is that right? I guess I should whip out a calculator. Yeah, 8.5. So that's Texas's deviation. Now I want to know how many standard deviations that is. So we calculated the standard deviation was approximately 3. We're just going to call it 3. So all I want to know is how many groups of 3 are in 8.5. So I'm just going to divide that by 3. So I'm just going to adjust my calculation. So if I take the deviation, which is that subtraction, and I divide by the standard deviation, it just tells me how many that is. Now here I definitely want a calculator. So let's use Google. And we'll just throw it down here. Texas, oops. So what did I do? I took Texas's value of 16.6 and I subtracted the mean of 7.9 and I divided by the standard deviation, which is about 3, and I get 2.9. And that's what's called a z-score. All a z-score does is it counts standard deviations. So this is approximately or exactly 2.9. Maybe it's approximate. It's probably approximate. Yeah, it's approximate. It's rounded. 2.9. And again, this is what's called a z-score. And what that tells me is that Texas is 2.9 standard deviations above average. And so in terms of determining outliers, I need you to be familiar with two techniques. One is extending that interquartile range by 1.5 times and looking to the left and the right of the of that interquartile region. And the other is looking at standard deviation and see, are there any data values more than 2 standard deviations to the right or more than 2 standard deviations to the left? And we can just simply calculate what is 2 standard deviations to the right of the mean, what is 2 standard deviations to the left of the mean, and then check out the data. Sorting the data is important to do that. So here, Texas is more than 2 standard deviations above because it's z-score, the number of standard deviations it is away from the mean. It's a positive 2.9, so almost 3 standard deviations above average. So that is unusual, okay? So Texas's percent uninsured is unusually high. That's what we have there. All right, so that's one of the biggest ideas in this section. In terms of summary statistics, you get most of the summary statistics you need by looking at StatKey, does them quick for you, or you can whip them out pretty easy in a spreadsheet. So again, numbers we're going to want for sure are the min, the max, range is optional, count's a good idea, the mean, the standard deviation, and then the quartiles. So we would want quartile 1, we would want the median, and we would want quartile 3. And so the commands for that, again, are quartile. And for quartile, you highlight your data and then state which quartile you want. So I want the first quartile. Median is pretty straightforward. I can either use the median command or the quartile command because it is quartile 2. Median's easier. Don't want to include the US there. And quartile 3. So those are all my summary statistics. Oops, too far. Oops, premature. Comma 3. All right, so I can get those on the spreadsheet and I can get them on StatKey. Let's see, what else do we need to look at here? I think I got all the big ideas. So this week, things you need to do are read the textbook. So I got the web book up here, which is a nice thing to look at. You can bring up the table of contents and jump around to whichever section you wish. And this is a slightly shorter week than other weeks, so you should get through this one pretty quick. There's a PDF copy of the book right here, using a spreadsheet to do standard deviation. And we don't need to calculate standard deviation by hand, ever, really. You'll see some videos that we do that, but pushing the button in a spreadsheet is great. You get some practice problems to do, you get critical thinking to do, and this time you're going to evaluate what your peers wrote. So you want to pay attention to those instructions right here about the peer evaluation. That's an important part of your grade this week. We've got the application problems. So please check those out. So four big assignments. You get some reading to do. You've got your practice problems, your critical thinking, including a peer evaluation, and your application problems. The application problems are more like the practice problems, except you only get one shot at each. So do those last, get them in on time. And that's it for this week. Take care, do good math. I'll see you in the future.